Yes. Okay, I'm so sorry, guys. I forgot to start recording, but this is pretty simple. Pause it and then copy everything down, but I'm just going to explain it really quickly. Looking at your periodic table, if the square is red, it's a gas at room temp. Blue, it's a liquid. White, it's a solid. Gray means that the elements are synthetic. We as chemists have to manufacture them. They don't occur in nature. So you can't like dig in the ground to find technetium. You have to make it in the lab. Okay, so I want to talk to you about 4 of the groups of the periodic. Oh, I should probably tell you what that means. A period is, oh dear. A period is a row. So it's like a regular table that you would see in your math book, except that we call rows periods. That's how the periodic table gets its name. And then we call the columns groups. So today we're going to start by talking about 4 of the columns of the periodic table that are special because they do special things. Other columns do other special things, but we don't need to worry about them for now. Okay, so looking at your periodic table, you have a front and a back side. The front side says periodic table of the elements on it. That's the front. The back side says electronegativities and common oxidation states. That's the back. I want you to be looking at the front side that says periodic table of the elements. All right, so on this piece of paper, I want you to label your groups. And so you're going to have to write small because the margins are small here. So really close to the top of the paper, in other words, if this is your column for hydrogen, I want you to like leave this space here blank. And so above the space, I want you to write for hydrogen 1A. The next column, if you're moving, yes, Sawyer? I sure do. Like a chicken with my head cut off. Does anybody else need one? Okay, so the first column, I'm not going to leave this space because I ran out of space here. So the first column is hydrogen, it is 1A. The second column is for, not helium. Why did somebody stop me from this nonsense? It is beryllium. Helium is over here. Right. So this is 1A. Beryllium is 2A. And then I want you to skip down through this like low column here. And then boron is next. He's group 3A. And then carbon is 4A. Nitrogen is 5A. Oxygen is 6A. Fluorine is 7A. And helium is 8A. These are what we call the A group elements. The low section that we didn't label are the B groups, and we won't talk about that. The B group elements, so like the ones in this section here, they are not as predictable. They have similar properties, but they're not as predictable because they have like a million different ways of bonding. All right, so I am going to go through 4 of the columns that I've labeled here and just tell you some things about them. And that'll be it. Well, I mean, not for the day, but the first group that we're going to talk about is group 1A. Group 1A is called the alkali metals. Have you ever heard this before? Did you learn this maybe in freshman year? 7th grade, sometime? When you weren't learning about the birds? The alkaline metals have very similar properties. If you are able to observe them, which I'll explain in a little bit, they are all white and shiny, and they look kind of silvery. They are all soft, so they're metals, but like, so there's a metal part of your desk, or like there's some metal around you. If you were to like squeeze it, it won't like move at all. But a soft metal is something that if you like squeezed it, it would feel like putty kind of. You'd be able to like mush it, I guess. But my favorite thing about the group 1A metals is that they're highly reactive. In fact, sodium, solid sodium metal, is so reactive with water it's so reactive with water that the moisture that's in the air will react with the sodium in an explosive way. So when my dad was in high school, he went to St. Mary Springs in Fond du Lac, and he's old now, so that was back in the days when it was an all-boys school. He and his buddy broke into the chem lab stock room. So like this room here, they broke into that at their high school, and they stole some of the sodium metal. So when you keep sodium metal in your stock room, because it's so reactive with water in the air, you have to keep it underneath kerosene. So like none of it can be exposed because it'll explode, it's so reactive. And so they took their little jar full of kerosene and sodium metal to the boys' bathroom, and they flushed it down the toilet. But it didn't get very far because it exploded the entire toilet from the wall. Like there was a gaping hole and like porcelain everywhere. It was on the news because, okay, so this would have been like in the early 70s. It was on the news because they couldn't figure out at all what had happened, like how this toilet came to be like absolutely destroyed. The other interesting thing is that they're so reactive that they react to completion. So have you ever gone to the grocery store and like when you're hungry and you buy the foods, do you always eat all the foods before they go bad? No, so there's like some waste there. But imagine this reaction is like going to the grocery store when you're hungry and then eating all of the food like instantly when you get home, all of it. So there was no evidence left over of the sodium that caused the toilet to explode. And so a couple of years before my grandma passed away, my dad's mom, we were at her house for like Christmas or Thanksgiving or something, and my dad was telling the story about how he had done this. And she was so mad because nobody knew. She was so mad when she found out. She made him leave the house. She like hit him with the wooden spoon and like made him leave. He was like in his 50s, and she kicked him out of the house. It was just the funniest thing. Yeah. So very highly reactive. Group 2A are the alkaline, so almost like alkali, but not. They are the alkaline earth metals. They are also shiny. They are reactive, but not as reactive as the 1A. But the interesting thing about the group 2A elements is that they are all naturally occurring. Are there 2 R's in occurring? Well, if there's not, don't copy down my bad mistakes. So that's where they actually get the name earth metals, because they're all naturally occurring and can be mined. Beryllium is the element that is I would say, I don't want to say like the active ingredient, but it's like the main element in quite a few gemstones. So like emeralds are made of beryllium. The garnet, I think, as well. So that's, I mean, if you like sparkly things. So just keep straight these names because alkali and alkaline are so similar that they can really, it's easy to mistake them. All right, can I move to the next one? Are you guys good? All right, the next one we're going to talk about is group 7A. So we're going to skip 3, 4, 5, and 6. They do interesting things, and especially group 4. Group 4 has carbon in it, and carbon does so many interesting and unique things that an entire branch of chemistry is devoted just to the study of carbon. That would be organic chemistry. And if any of you are thinking about wanting to go into the medical field, you'll need to take organic chemistry. Okay, so group 7A are called the halogens. And that word comes from the word halide, which means salt producing. And so not just the halogens produce salt, but because the main salt that we think of is sodium chloride, and chlorine is one of the halogens, that's where it gets its name from. Let's see, what are some interesting things? Oh, the halogens, group 7A, is the only group of the periodic table that has elements in all 3 states of matter. And of course I mean that like at room temperature, because you can make an element be any temperature you want. It's just that these elements occur naturally as gases, liquids, and solids. It's the only one. Halogens are really reactive. They do a lot of interesting things. Some are soluble, some are not. We'll talk about that later on. And then group 8A are called the noble gases. And they're called this because they are all in the gaseous state. They're all red. It's the only group of the periodic table that has all gases, except for our synthetic friend. In fact, when element 118 was first discovered, there was a huge controversy about it. This was like in the early 2000s. There was a lab who claimed to have isolated the element, and it was only stable for 4 nanoseconds, which is a pretty small amount of time. And they had lied about their data. So they had gotten like awards for being the first to discover the element, and but it was all like falsified, and it was like a very big scandal in the scientific community because scientists are not meant to be falsifying information. Okay, so the noble gases, they're all gases, and they're called noble because their claim to fame is that they do not bond with anyone. Now, technically, that's not true. And so one of the things that you'll see if you take AP chemistry with me next year, or if you take chemistry in college, you'll see that all of the things that I'm telling you today are actually lies. When I tell you it's always this way, or there are no exceptions to the rule, or this is a rule because it's always the way it happens, every time you like advance in your study of chemistry, you'll learn where I have betrayed your absolute trust and what I've been telling you is lies. I'm not doing that to break your trust, but because we have to start someplace, and now is not the time for me to tell you the exceptions. Once you have had some chemistry under your belt, then we'll explain why sometimes the noble gases bond, but not today. So the nobility are the people who don't have to work for money because they're just naturally rich, and so that's where these group of elements got their name. They're noble gases. They don't have to bond in order to be satisfied with their life. They just can be themselves. It's good that they don't do a lot of bonding because then they're able to be used for things that require reactions to not happen. Like for example, my light bulbs in the room probably have argon gas in them because argon is non-reactive. And if we had oxygen in there, because oxygen is so flammable, if the wire of the light was getting hot, it would explode because the oxygen would be ignited. So it's a good thing that they don't react. Any questions about those four groups? What do you need to know about them? You need to know the names and where you can find them. All right, let's take a 6-minute brain break, and then we'll come back and I'll teach you about the periodic table trends.